Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapters of DC voltage, resistors, electric power and energy. This exercise was a previous one in the Brevet exams in 2007 second session, second exercise. The title of this exercise is Normal Functioning of a Lamp. The object of this exercise is to study the functioning of a lamp L that carries the inscriptions 3 volts, 3 watts. Notice that till this moment they didn't mention anything about this electric circuit, then we are not allowed to use it. Now part 1 of this exercise, resistance of the lamp L. The lamp L is connected in a convenient circuit so as to function normally. And here by the convenient circuit they mean an electric circuit other than this which is given here. And because the lamp L is functioning normally, so the applied voltage will be equal to the rated voltage and the consumed power will be equal to the rated power. Now, number 1, part A, they are telling me what's the voltage across L. Let's say since the lamp L is functioning normally, then the applied voltage is equal to the rated voltage of the lamp L. So the answer is given by 3 volts. Now in part B, what is the power consumed by L? Since the lamp L is functioning normally, then the consumed power is equal to the rated power of the lamp L, which is given by, in this case, 3 watts. Now in part C, they are telling me deduce the value of the current I0 carried by L, and the word deduce means that we need to use the part just previously before. In the previous part, we already talked about the electric power across the lamp L, and we already know the applied voltage across the lamp L. Then we can deduce the value of the electric current using the following formula, which is given by P is equal to U multiplied by I. Now constructing the triangle of this formula, P will be at the top, U and I at the bottom. We are interested in calculating the value of I, which is denoted by I0 in this case. Then I0 will be equal to P divided by U. Now the value of P is equal to 3 and the value of U is given by 3. This is equal to 1. Since P is in the SI and the value of U is in the SI, so the value of I0 will be in the SI, which is amperes. Then I0 is equal to 1 amperes. Now what does I0 represent? I0 is the rated current. Here, because we calculated the value of I0 when the lamp L is functioning normally, then we can consider the value of I0 to be the rated current of the lamp L under which it functions normally. Then here we have calculated another indication corresponding for the lamp L, which is given by 1 amperes. Let me say that I0 is equal to 1 amperes. Now in number 2, they are telling me L may be considered as a resistor of resistance R. Show that R is equal to 3 ohms. We know that the resistance can be calculated using Ohm's law. Then let's apply Ohm's law to the lamp L. Apply Ohm's law to L. Here we can use all of these indications because the lamp L is connected in a convenient circuit and it's functioning normally. Moreover, we can use these indications since we are calculating the resistance R of this electric component, which is the lamp L. The Ohm's law is given by U is equal to R multiplied by I, constructing the triangle of this formula, which is given by U over Ri. Here, because we have multiplied and U will be at the top, we are interested in calculating the value of R, so putting our hand over R. R will be given by U divided by I. R is denoted by small r, and U divided by I0. The value of U is given by 3 volts. This represents the voltage because it has the unit of volts. Then 3 divided by the electric current. This is the electric current because it carries the unit of amperes. So this will give me 3 because the voltage and the current is in the SI, so the value of R will be in the SI, which is ohms. Then the resistance R of this lamp is given by 3 ohms. Now in number 2 or part 2 of this exercise, functioning of the lamp L. We connect L in series with a resistor D of resistance R is equal to 17 ohms across the poles of a generator delivering a constant voltage UPN is equal to 12 volts. A current I passes then in the circuit. They mentioned this circuit, then now we can use it. Okay, this electric circuit consists of a generator that delivers a constant voltage UPN is equal to 12 volts. The trick in solving such type of exercises is to write applied voltage on the electric circuit itself. Then this is 12 volts. Now the electric component D, let me make some space here. The electric component D, which is a resistor, has a resistance of R is equal to 17 ohms. And because the circuit is a closed circuit, then it's being traversed by an electric current I. Now part 1, part A. Determine the value of the resistance equivalent to the combination of R and R. Now small r represent the resistance of the lamp L and capital R represent the resistance of the resistor D. They are asking me to calculate the value of the resistance equivalent to the combination of R and R. First, let's mention that D and L are in series. Then the equivalent resistance in this case is given by R equivalent, which is equal to R plus R. Now the value of R is given by 17 and the value of small r is given by 3. This will give me 20. Since R and R both are in deci, which is ohms, then the value of R equivalent will be in ohms. Then R equivalent is equal to 20 ohms. Always whenever we calculate equivalent resistance, we need to mention that they are whether in series or in parallel. Moreover, we need to redraw the electric circuit containing this equivalent resistance. Now this is, let me draw it here. This is the generator G, this is the point P. Now this is the point B. Here, point C will disappear because D and L are replaced by the equivalent resistance R equivalent. Now this is the point N. Through N here we have the closed switch K and F to R equivalent. This is N. This is the closed switch K. This is 12 volts traversed by the electric current I. Now in part B, they are telling me determine the value of I. Now R equivalent is equal to 20 ohms. We need to determine the value of the electric current I traversing R equivalent. In this case, we know that the voltage of the battery is given by 12 volts. And because here we only have this electric component, which is R equivalent, then the voltage across R equivalent will be 12 volts, and this can be explained either because these two are in parallel, then according to law of uniqueness of voltages they have the same voltage, or we can prove it using the law of addition of voltages, because UPB is equal to 0 connecting wire and UFN is equal to 0 close the switch. Then in this case we know that the applied voltage across R equivalent is equal to 12 volts and its resistance is given by 20 ohms. Then we can apply Ohm's law. to R equivalent. This law is given by U is equal to R multiplied by I. Constructing the triangle of this formula, U will be at the top and R and I at the bottom. We are interested in calculating the value of R, which is denoted by, we are interested in calculating the value of I. Now I will be given by U divided by R, which is the voltage UBF, and the resistance R equivalent. Now the value of UBF is equal to 12 and the value of R equivalent is equal to 20. Because both of them are in the SI, so the value of I will be in the SI, which is amperes. Plugging this on the calculator will give me 0.6 amperes. Then I is equal to 0.6 amperes. So here the value of I is equal to 0.6 amperes and the value of I is equal to 0.6 amperes. Now in part C they are telling me L doesn't function normally. Why? In order to describe the functioning of a lamp or an electric component, we need to compare the inscriptions with the applied or traversed, the applied voltage or traverse current. In this case, we only know the rated current, then we can compare the traverse current. We can compare the traverse current with the rated current that we already calculated in part 1 of this exercise. So notice that in this case, the traverse current is given by 0.6 amperes, whereas the rated current is given by 1 amperes. This traverse current is traversing the resistor D and the lamp L as well, because they are in series and according to law of uniqueness of currents they have the same current. Then let's say we are in part C. Since the traverse current, which is in this case 0.6 amperes, is less than the rated current of the lamp L. This is because 0.6 amperes is less than 1 amperes. Then the lamp L will not function or function weakly. Now in number 2, they are telling me to make L function normally, we replace D by another resistor D prime of resistance R prime. R prime must be smaller than R. Why? Now here the lamp L is functioning weakly or doesn't function because the traverse current is less than the rated current, which is 1 amperes. So in order to make the lamp L function normally, we need to increase the value of the traverse current in order for it to be equal to the rated current. And this happens when the resistance R of D decreases, because we know that whenever the resistance decreases, the electric current increases. Then let's say, since or let's say when the resistance decreases, then the electric current increases. Then for this reason R prime must be smaller than R. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.